Welcome to the part 3 of this Python series. In our daily life, we will try to do something. Sometimes it will be successful, sometimes it doesn't. So in such case, in order to handle the failures, we can use the try except. We will see how do we use it in Python. So if you see here, the overall structure goes like this. So there is going to be try. Within that, we will try to keep whatever we want to try. And in case of a failure, we wanted to handle that in the except block. In case of a success, then we will handle the success execution in the else block. And irrespective of the result, so we are trying something, whether it is success or failure, we wanted to do something. That is what we do in the finally block. So these blocks, some of these blocks are optional. If you see here, we can just use try except, or we can use try except finally, or we can also use a try except else finally. For instance, to do is that I have a value 10 and I wanted to divide the number 10 with the provided input. So in which case, if a provided input it's greater than 0, then now we should be able to divide the number 10. But if it is 0, you cannot divide the number 10, right? In which case, like, it is going to throw an exception. So we are not expecting 0 to be a valid input, but sometimes like a user does. User provides a 0 as an input, right? So like, let me run this program. Now let me provide the value 5. So in which case it is going to give me the result like 10 divided by 5 equal to 2. But like now again try me. So in this case I'm giving the value 0. So in this case, when I try to divide the 10 by 0, it is not going to fail because like you cannot divide any number by 0. So in that case, so the try, within the try block, we are trying to divide, but as the failure happened, this is what we expect to print, right? And this is exactly, gets printed. And finally, like, irrespective of the failure or success, this particular statement will always get printed. So now let's extend this one. So if you see here, you can have multiple except, right? So like in this case, like, let me run this one. So instead of the number, let me give a letter as an input, right? So in this case, it says that it is an invalid input, right? So when you try to divide number 10 by the letter A, it will throw an exception. The system Python will throw an exception saying that value error. Now this particular except will catch that failure and it will perform the action that it instructed to do, right? In this case, we just print invalid input, and as always, like, we always print the finally statement. The idea is that irrespective of the outcome, you want to perform a specific action. For instance, you want to do some sort of a cleanup, so that is what you will keep in the finally block. Block, it's to try something, and in case of a success, else will run, and in case of a failure, except will run. And finally, irrespective of the outcome of the try, this particular block will get executed. Try to understand the object oriented programming. Like, let's see, like, how do we do object oriented programming in Python. Whatever we have created or discussed, it's the procedural programming. In that sense, how you will define a function, and like there is going to be a main function that is going to make a call to all your functions to perform a specific action. For instance, we have created the grocery store checkout system. If you closely look at it, we have defined a couple of functions, and like we have defined the main function through which we control the execution. So the procedure programming, it's all about a set of a function and procedures through which you will perform a action. Wherein, like, in the object oriented programming, the thinking is slightly different. Object oriented programming, it's all about object or things. We can use the terms things, objects, instance interchangeably. So when I say object or a thing or instance, it's all referred to the same thing. So before we try to understand the object, we need to understand the operating environment. So what is the operating environment? So now in this image, if you see here, we are talking about a classroom. So the operating environment, it's classroom. So if you discuss about a library it's operating environment. If you operating environment in this classroom, what are the things that you see? You see students, you see teacher, and you see many other things. So whatever we wanna in our application as object for scenario, you have a virtual classroom with a teacher and multiple students. So the teacher will have a name, age, education, and she will teach, give a homework, review the homework or whatever is that, right? So the name, age, qualification, these are all known as attributes of that particular object, and she will have some skills like teaching, giving the homework, reviewing the homework. These are all known as or method of the object. Likewise, student object will have their own properties and their own behavior. Takeaway here is that object will have their own properties and behaviors. Let's move forward. So this is what we discussed. So student, it's the object in the operating environment. Student will have a data or attribute as well as behavior or a method. So what is class, right? So class is the definition of this object. So it says that, hey, student will have these kind of a data or attribute, and student will have this kind of a behavior or a method. So class, it's nothing but the definition. It's not the actual object, but it is the common definition. See here I have a class person. A person will have certain attributes. This particular class will have a certain functionality. The instance of the class, it's the object. For instance, here you have a car class. So based on the definition, you will create a number of cars. So each car, it's considered as the object. So when we really talk about a class and object, a class, it's the definition. Object, it's the instance of that particular class. Let's look into some of the examples here. So let's talk about the car. So car will have some attributes like car color, model, speed, and it will have a certain behaviors like it can start, stop, accelerate, or whatever is that. So car, it's the class, which is nothing but a definition, and for the class you have to create an object. Here we create an object called a CRV, which is nothing but the instance of the class, right? And now we can do some actions on that. CRV can start, accelerate, or whatever is that. We also have a bank account. So let's say I have a savings account, so that has certain attributes, certain behaviors. So I create an instance, Karthik saving account, and then do a deposit with it, check the balance or whatever is that, right? Likewise for student will have a name, age, grade, or whatever is that. He will study, right? So we will create a student like Karthik, it's the instance of student, and he can study. It is very clear what is class and what is object. Define the class. So this is how you define a class in Python, right? So you say class, give it a name to the class, and whatever the definition that you have, you will keep it. Right now I don't have any definition. I'm just going to create an empty class. And when you have a class definition, you can create an instance or an object or a thing, right? So I'm creating an object called lucky, but it will not have anything because there is nothing in the class definition. So it is going to be an empty object. So now let's see how do we create certain attributes to this particular dog. So let's assume that this dog will have a name and age, right? To do that, you have to create something called init. We will discuss in a moment, but it will take 3 parameters in this case: a self, name, age. You can ignore the self, right? So just focus on the name and age. So now what we are saying is that this particular class will take 2 attributes, name and age. And the way you pass the name and age, when you create the object, you say what is the name of that particular object and the age for that particular object, right? Print here, it will say my dog name is Lucky and age is 3. I'm reading this value here my object name is lucky dot name, the object dot its attribute, right? So in this case attribute, it's nothing but name and age. So I say object lucky dot name, object lucky dot age, and I get that information. How do we get this lucky and age? It's pretty simple, right? When we create the object, we pass these values. So whatever the value that you pass, it will be assigned to that particular object, right? So now let's talk about the self, right? Because like we know what is this name and age, but we do not know what is this self and what is this init, right? So we'll discuss first the self, and then like we will come back and discuss about this init. So self, it's the keyword in Python. So basically that refers to the current object. In this case, when I say like a self, it is going to refer the object lucky. So the way Python will use this, it's like this. So when you create an object lucky and then like pause whatever the attributes that you wanted to have it, internally Python will say, hey, like the class call this particular function like init. It's a special function, right? So it's a constructor. We will come back. So it is going to pass the object name, which is lucky in this case, and then like pass all other attributes that you passed, right? So basically like you will not be pausing anything for this self, but then like internally Python will make a call to the init method and the like pass the object that you're going to create, right? So in refers to the object by itself. You really don't have to pause anything for the self. I hope this is clear now. So now let's move forward, right? So we know like how do we create a single object? Can we create a multiple object? Of course we can create a multiple object because we already have the definition, and based on the definition we can create n number of object, right? So I have created lucky. I will also create one more object called buddy and pass its corresponding attributes, right? So here like instead of lucky I call it as buddy. Age is 2, right? So on the like I print all these values. So likewise, like when you have a class definition, you can create multiple object or instance of that particular definition. So now let's talk about the init method. Init method, it's known as a constructor. It's a special method. So when you create an object from the class definition, it is going to automatically call this init method and pass the attributes that you are passing in. So it will take one more extra attribute, the self attribute that we already discussed. The self attribute, it's nothing but the reference of your object by itself. You don't have to pass it. Python will internally make a call to this init method and then like pass the object, right? Now let's move forward. So now let's assume that this dog also bark, right? So just have the name and age. It will also have some behavior. Like in this case, dog will bark, right? So in that sense, like I can define the method here, and like I can call the method by the object name, right? So likewise, like lucky.name, which is the attribute. In this case, lucky.bark, which is that particular behavior or a method. So you can define a method. If you see clearly here, this is part of the class itself, right? So that is why like we have used the indentation, like 4 dots we have it here. So this definition, bog definition, it's part of the class. So whatever the object you create out of this particular definition or a class, it will have this particular method. You can make a call to this method by the object name and the method name. So here in this case, it is going to see woof for both the dogs, right? So lucky says woof and buddy says woof. So now let's see, like let's implement a simple real world scenario here, right? I wanted to have a bank account. So in bank account, what you will have a owner name, balance, and the like there are certain behaviors you will have or actions you will perform on your bank account. You will do a deposit, you will withdraw, you will check the balance. So now what we are saying is that bank account, I'm creating an account, I'm trying to get the balance. So it is just going to print whatever the balance, because I just deposited 5,000 here, right? I did not do create the object. I said the owner it's Karthikeyan and then the balance it's 5,000. Here if you see here, the default balance is 0, but the like as I have passed 5,000, the balance will be added into the account. I have created account with $5,000 deposit, and then like when I try to get the balance, it is going to tell me, hey, the balance it's 5,000. I can also perform the other operations. So let me do this. So instead of that, let me add some deposit. Let me also withdraw some money. Now let me print the balance here, right? So let me print the account balance. So you can use the balance attribute, or you can also use the method here. So if I do it here, so it says that now I deposited $1,000 because like I opened the account with 5,000. So then I deposited 1,000. So balance is 6,000, and withdraw 2,000. So balance is 4,000. Now I'm printing the balance. So what we have done is that we created a simple definition, banker definition, with certain proper attributes, and like we are also having certain methods, and we can use the methods to perform operations on the class. Forward and discuss about something called abstract class. Have a common behavior in your system between the classes, then you can define the abstract class, and you can keep all your common behaviors in the abstract class. So which means that whoever inherits in the sense like here, cat inherits from animal, dog inherits from animal. So which means that whatever we define in the animal, that will be applicable to the cat as well as to the dog, because like both of those are animals, right? So you can define the common behavior in the animal class and let it inherit to the other classes. So the talk about the abstract class, there are two things that we need to understand. One, the abstract class itself, and there is something called abstract method. We will see the difference between these two. Of the abstract class or abstract method, you have to import them from the package ABC. So here if you see from ABC, from the package ABC, we are importing the ABC class as well as the abstract decorator. Create the animal abstract class like this. So we create a class called animal, but then like it inherits from ABC, that converts the animal class as a abstract class, which means that again you cannot create an object for the animal class. But what we can do is that we can inherit the animal to a dog and a cat, like what we have shown in this image. So we are converting this animal as an abstract class, which means that you cannot create an object for the animal class itself, but the animal it's inherited to the cat and dog. Thus are considered as a concrete class. So you can create a object for the concrete class. So if you see here, created ABC to animal, that converts the class animal as the abstract class, but we inherit animal to the dog and animal to the cat. So these two are a concrete class. It's not a abstract class, rather like these classes are a concrete class. So you can create an object only to the concrete class. In this case, dog and cat both are considered as a concrete class, and then like you can create an object. So if you see clearly here, both the and the cat are empty class, but then like we are making a call to the make sound. This is coming from the base class. The So if you see here, what we have done, we have identified the common behavior and moved the common behavior to the abstract base class and inherit the abstract base class to the subclasses. So that way, whatever the parent class, in this case the animal class has it, it is inherited to the cat and dog, the subclasses, and they can use it. So we really don't have to do the implementation at the subclass level, right? So now let's move forward and try to understand the abstract method. So though this is make sound, it's a very common behavior. It is not to say that all the animals will make a similar kind of a sound, right? So in that sense, what we are saying here is that hey, animal will make a sound, but then like it depends on the individual animal to decide what kind of a sound it is going to make, right? So now what we are doing here is that we are converting the animal class as a abstract class, which means that we cannot create an object for that, but we are also saying that make this method as an abstract method, which means that whoever it is going to inherit the animal class, they need to have their own implementation for this particular method make sound, right? So now there is no implementation for the make sound at the base class level, but the like whoever it is going to inherit, they have to come up with their own implementation. So if you see here in the dog class, so we are having the definition for the make sound. Same way like for animal cat class also, we have the make sound definition. So now if you call the make sound for the dog and the cat, the output is going to be different. So in our previous demo, so when we make a call to the make sound in both dog and cat, it just says animal makes a sound. It doesn't make any sense. Animal will make a sound, but then like what sound is that, right? We do not know. So that is what we are doing here. So we are converting a method as abstract method, which means that the subclasses or the child classes who is going to do the inherit from the parent class, it should have its own implementation. So that is what we are forcing it here, right? So let's see like how this help us in the real world. So now let's try to understand. So if you see here, like we are talking about a driver license. So the driver license for a different categories of a drivers, like truck driver, car driver, or a bus driver, right? So everybody needs to do a test. Like the test will be like signal test, behind the wheel test or whatever is that, right? So the test pattern it is going to be the same, but then like it depends on the category of a test. The test will vary, right? So we will have a parent class which will cover all the common behaviors, and the like it depends on the category you will do the proper implementation. Likewise, if you talk about a banking system, so let's assume that we are talking about the saving account and the credit account. Both will have a common methods or a common behaviors. Basically, like you will do a deposit, you will withdraw, get the balance, right? So you will perform these kind of actions on both the savings account and the credit account. But the like these methods are common for both the type, right? What you can do is that you can move the common methods or the common behaviors to the abstract class, and then like make these methods as the abstract method. So in that sense, whoever it is going to inherit, in this case the saving account and the credit account, it has to have its own implementation. So we will see like how do we do this, right? So if you bank account data class, so it just handles the data, right? So it has the owner and the balance. Now I also have a bank account service interface. This is marked as the abstract class, and it also has some abstract method. Now if I come down, I have a savings account that inherits from the above bank account service interface, which means that it needs to implement all these method. So it does implement the deposit, withdraw, and the get balance. Likewise, I also have a credit account that is also inherit the bank account service interface. Now it needs to do the implementation. It has the implementation. Now if you see here the way it is done, so we have a base class and we have a saving and a credit. So we define some of the abstract method, both the subclasses saving account and the credit account implemented all the methods. Now we can make a object to this saving account as well as to the credit account and perform the actions. So this is how we can use the abstract method and the abstract class. Let's move forward. Now let's talk about inheritance. So inheritance basically means that we will have a parent class and subclass. So we will have the common attribute, common behavior defined in the base class, and we will inherit the same into the class, so which we already done in our previous video. So if I just go back here, if you see here, we have created a base class called bank account service interface, and that is what we inherit into the savings account and credit account. This is a kind of inheritance. Now let's go back and try to understand. So if you see here, I have a person and I have a student. So if you see here, student inherits from person. So whatever it's defined in the person class, that will be available in the student class as well, because like this is the parent class. From parent you can import everything into the student class. So there are multiple types of inheritance are available. So if you see here, like there is a single inheritance where like you will have a base class and a one child class, and we have a multiple inheritance wherein like you will have a two different parent class and inherit into the single child class. And we will have a multiple inheritance, like one class from another class from another class, right? And we will also have a hierarchical inheritance, like from one parent to multiple child. And we will also have a hybrid inheritance, like whatever the pattern we have discussed so far, you can just make use of the patterns that you are interested in. It doesn't have to be this way or that way. You can use single inheritance, multiple inheritance, or whatever is that. Make your own kind of inheritance. So that is kind of a hybrid inheritance. So now if you see here, let's talk about the simple inheritance. So I have a dog class, and the like puppy inherits from dog. So now if I say hey, like cow, dog bark, and the like puppy bark. So if you see here, when I say dog dot bark, it says oof, and the same thing we are like overriding the bark class, right? So though it is not a abstract method, you really don't have to override, but sometimes you have to override as well. So that is what I am showing here. So there is a way wherein you can override the implementation from your parent class. If you don't override whatever it's there, you can make use, but then like sometimes you may have to override. You can also do that. Also you can have your own implementation. So if you see here, the play method, it's not part of a dog, but the like a play, it's only for the puppy, right? So you can have your own method in your subclass. So this is kind of a simple inheritance, right? So likewise, you can do the all other kind of inheritance. Now let's move forward and try to understand polymorphism. Think of a scenario. You are a McDonald's restaurant and a family comes in. If you see, each of them are your customer and the customers will eat and drink. But again, there will be some adult customer, there will be some customer. So adult will take adult meal while kids will take kids meal, and adult will take coke while kids will take juices. So if you see here, you have a customer as a base class, but then like from a base class you have a two different classes, adult and customer, and in the context the behavior will change. For instance, if a given context it's for adult, when you call eat, it will say eat adult meal. But with the kids context, when you call the eat, it will say eat kids meal, right? What we are saying is that customer is a customer, however like the behavior changes depends on the context. So if you come down here, we have a restaurant and we are asking, hey, like you are a kid or a adult, and then like based on the input we create the corresponding class. For instance, if a provided input it's for adult, then we create a object of adult and we call eat and drink methods. Let's run this program. So now let me say adult. So if you see here, it says adult meal and drink coke. The same program, but this time around instead of adult, if we say kids, now it is going to say eat kids meal and drink juice. So same program behaves differently depends on the context. When you run the program, depends on the incoming context, the overall execution slightly changes. Another scenario here, let's assume that the same family is going out and walking. So each of them are a person. So we define boy, girl, men and women. So they all walk, but the way they walk it's slightly different, right? Again, depends on the context. When you call walk, the walk will be little bit different. So now if I run the same program and if I type boy here, if I just come down here, it says boy is walking playfully. And if I do the same thing for the girl, then it is going to tell me girl it's walking gracefully. So basically like what we are saying is that we will have a group or a family of classes with the similar behavior, but the behavior slightly changes between all of these classes, and at the runtime choose a specific class depends on the need. The program execution completely changes depends on the selected class. So that is what we will do with polymorphism. Move forward and try to understand encapsulation. So encapsulation, it's the way of hiding the unwanted information. For instance, that you are a car manufacturer, you don't want everybody be able to access your engine, right? For instance, a typical car buyer has nothing to do with your car engine. All he needs to do is that the engine need to run, but he is not going to open the hood and try to fix something within that engine, right? That is kind of a considered as a protected. Basically, like people or some mechanics should be able to access your engine. So there are quite a few components considered as a public, few considered as a protected, few considered as a private. For instance, the steering wheel it's considered as a public, everybody should be able to access this. Of course, your team as well as the external mechanics should be able to access the car engine. Private, it's like how do you build this engine, it's some internal which you don't want to expose. Picture it clearly explains the difference between public, protected and private. Saying here is that public will be accessible from inside and outside. Protected should not be accessible by outsiders. Private should not be seen and accessible by the outsiders. Here, Python follows a naming convention here. For instance, if you don't have anything, just the name, it is considered as public. But if you have a single underscore, that is considered as a protected. But if you have a double underscore, it is considered as a private. So if I come down here and if you see here, this method, it's a public method because there is no underscore here. So I can create an object like here I have a class, it has a behavior or a method. So I create an object and I will make a call to this particular method. But if I come down here, the protected one, if you see here, it has a single underscore. This makes the method as a protected method. While I can still access this method, it is not recommended. Basically, let's talk about the private method. If you see here, this particular method has double underscore that marks this method as a private method. If you try to access this private method, it is definitely going to throw an error. So basically the private method and the protected method will not be visible to the outsiders, but in case if they know that there is a protected method and there is a private method exist, they can very well access the protected method, but they can definitely not be able to access the private method. So using these access modifiers, you can control what you want to expose to the outsiders and what you want to control. And that is what the encapsulation provides. Quickly discuss about some of the tools and libraries that we can use for data analysis in Python. First, we will look into NumPy. So whenever you wanted to work with array, you will be using NumPy. NumPy, it's a numerical Python. To install NumPy, you have to use a pip install, the name of the library, in this case NumPy. Then you have to import that NumPy. So here we are saying like import NumPy as np. So basically this is just alias. So instead of every time say numpy dot, hereafter you will say np dot. So first we will create a single dimensional array. So this is our data. So to create the array, you will say np dot array. So basically it is going to create array, and here like you will have a single dimensional array, right? So now if you see here, so we are printing the array and the like a shape that is going to give us the shape of this particular array, and you can perform a certain action like sum, average, mean, medium, all of those can be done. So you can run it and see the values printed here. You can also create a two-dimensional array. So here if you see here, like I have a city and the like the day. So here like I have the two dimensions. So if you see here, like this is one city and this is the another city. So I just create this. So if you see here, the shape, it's like a two, like there are basically like two set of arrays and each array has 5 elements. So you can very well create a two-dimensional array. And you can also create a multi-dimensional array. So if you see here, like I have a company, each company will have 3 days. So I have two companies, 3 days, and it has some of these stock values here. So you can create like this. So if you see here, it has two companies, right? So you will have a two arrays here, and each company have 3 days. So you will have 3 arrays here. Within this company you will have a 3 arrays, and each day will have 4 values. So each array has 4 values. So likewise you can create multi-dimensional arrays with NumPy. Then you will also have a SciPy. So SciPy, it's basically a scientific Python. So this is the extension of NumPy. So whenever you want to perform a scientific operations, you can use a SciPy. Then you will have a pandas. So basically like whenever you wanted to work with the kind of a CSV file, then you can use pandas, a CSV or a database. You can use the pandas to work with this kind of a data. Again, like you need to install pandas. So pip install pandas. Then you can again create a alias, and then like see how do we use the CSV file here. So this is my CSV data, and then like in order to consume that CSV in pandas, you have to read the CSV file. So if you see here, panda.read CSV, name of the CSV file, and then like you will have a data frame. So data frame, which is nothing but the representation of the actual data, and then like here you can perform certain actions. So if you say head, then it will print the first 5, and if you say tile, then it will print the last 5, and you print the data frame by itself. Then you can access the specific column. So you can say like a data frame, that call name of the column, and you can also see the index. You can also use the index. Then you can also access the specific element using the row number and the name of the column. We have a meta plot. So whenever you wanted to create a graph or a plot, then you can use a meta plot. So you can create a line plot or histogram, scatter plot. So if you come over here, like It's pretty simple. All you need to do is that you need to have a matrix or a array using which you should be able to build the graphs that you want to have, right? So you can build all these graphs using Metaplot. Then we also have a Cban. Cban, it's the extended version of the Metaplot. So this is more for a statistical data visualization. So whenever you wanted to work with the machine learning models, probably you will be using the Cban. So if you see here, this is again like it's pretty similar. However, like this will give you a lot of more information than the Metaplot library. So it's pretty simple and straightforward to use these libraries. Then finally we have a scikit-learn. So whenever you wanted to build a machine learning models, you can use the scikit-learn. It has all these algorithms that you wanted to have to build your machine learning model. For instance, here like we are building a regression model. So basically like we have this data, and using which we are creating a linear regression. We create a model and predict the value, right? So use these libraries to do your data analysis, and also you can build your machine learning model if at all you are interested in. That's all I have for this video. Thank you for watching.